Alrighty, so here's an introduction to Coulomb's law. So let's talk a little bit about electric force. Charges exert forces on one another. And you're going to see a lot of similarities to gravitation here because this is a universal force. It's a field force. Contact between the two charges isn't required. It just exists and there's a force. And we know that like charges repel and opposite charges attract, and in order to make that movement happen, some sort of force has to exist. A couple different things about the force is that force decreases rapidly as those charges move further and further apart, and the forces on those two charges are equal and opposite. So here's Coulomb's law written out, and you'll notice it looks a lot like Newton's law of gravitation, but in this instance we have charges instead of masses, and we have a different value for the constant. So the electric force between two charged objects is directly proportional to the charge on each of the objects and inversely proportional to the square of the distance between them. And so you have electric force is equal to K Q1 Q2 over R squared. Got to be careful with that square in the denominator, and also watch for order of operations on your calculator. And another difference between the gravitation and Coulomb's law, besides charges versus masses, is this one can also attract and repel. It's got two different directions to it. So if your force ends up being negative, then the two charges that you had that you're working on have opposite charges, and so they're going to attract. If the force turns out positive, they're the same, and it's going to repel. And the idea of attract and repel is going to tell you what direction those charges are moving. So here's Coulomb's law again. Forces in newtons, the charges in coulombs, distances in meters, and there's that constant I was telling you about, 9 times 10 to the 9th Newton meter squared per Coulomb squared. So it is a different constant. Basically the same setup. Should look familiar if you think back to Newton's laws. And just a couple little details about it. It is for small charged particles. And we'll use some examples that are big, like charged balloons and other things, but really it applies to the smaller charged particles, electrons, protons, atoms, molecules, ions. And if you want to increase that electric force, you have to either increase the charge or move the charges close together. And like I said before, if that force ends up negative, then the charges are oppositely charged because it's a negative times a positive, and they're attracted to each other. And on the atomic level, if the attractive forces are greater than the repulsive forces, so it's pulling together, then a molecule is formed. So this kind of gives you the basic idea behind how chemical bonding happens. Very, very basic though. Alrighty, bye-bye.